So today I have a problem that came from a student and thought it was a little interesting, that you guys might like it. See if you can take a crack at it before I start. And we're just using algebra to solve this. Nothing more fancy than you'd find in algebra. So two adjacent circles with radii of 5 units are centered at 0, 0, and 6, 8. Find the equation of their common tangent at their point of intersection. Okay, so I've already drawn this, and I've drawn it using the graph, the scale of the graph in the background. So we can, it's not perfect. You can see this blue circle's a little bit, I don't think I got it quite centered. Let me see if I can move this puppy. Like I get a little, like, ooh, that's better. That's pretty close. That's pretty close. Let's get this. That's about as close as I'm going to get it. Okay, there we go. So we will get a reasonable representation, almost to scale, of this problem. So there's our two circles. They have a radii of 5 units, centered at 0, 0, 6, 8. Find the equation of their common tangent at their point of intersection. So point of intersection is going to be right there. And we want to find the equation of the tangent. So let me change this color there. All right. So the tangent line, and this is going to be the one little kind of hard part to try to draw this accurately. That's not too bad. It's probably off by a little bit, but it's enough to give us an idea. It's enough to give us an idea. It's pretty close. It's pretty close. All right, so there's our tangent line, and that's the goal here, is to find what does y equal? What's the equation of this line? First thing that I would do is I would look at these two circles and said they have a radius of 5. They each have a radius of 5. All right, so that means from the center to that point of tangency, I have that right there. And from this one, I can have from the radius to the point of tangency. And that is actually forming a straight line. It really is. It's a straight line all the way through. Those lines connect. A line segment, in this case, we want to be accurate, because it doesn't go on forever. It's not a line. And it is 5 and 5, total length of 10. But I'm more interested in the 5 and 5, more so than the 10. Because if it's 5 on either side, then that point in the middle is the midpoint of this line. So to find a line segment, I keep saying line segment. When we are talking about this point of tangency, that point of intersection, it's going to be the midpoint of this line segment. How do you find a line segment? A midpoint. It's early, still haven't had my coffee. How do we find the midpoint of this line segment? The way you do that is you take the average of the x's and the average of the y's, and that's your midpoint. It's written in a way that, frankly, I think makes it look harder than it is. But they'll be like x1 plus x2 over 2, and the y coordinate is y1 plus y2 over 2. And that becomes our midpoint. But it is just saying the average. So our x's are 0 and 6. And we have 2 of them, so we're going to divide by 2. There's our average. And our y's are 0 and 8. Again, dividing by 2. So see, it is the same as their formula. Of course it is. It just it isn't in reality, I think, as fancy as the formula makes it look. So 0 plus 6 is 6, divided by 2 is 3. And for our y, 0 plus 8 is 8, divided by 2 is 4. So our midpoint is 3, 4. Okay, now that's important. I now know that this point is the point of intersection, but it's also a point on that line. That will come into play later. Okay, now what else do I need to know? I know a point on the line. There's one other very crucial fact. Well, I have 2 options, actually, for crucial facts that could give me the equation of the line. One would be a second point on the line. From that, I can find the equation. Or the slope of the line. Either of those 2 things. Which of those is going to be possible? Well, here, slope is our key. Because any line that is tangent to a circle is going to form a right angle with the radius. So this right here, that's a right angle. Right angles all around. Right angles. So these lines, this line and this line segment, I keep saying line. Bam, stop saying that. Line and line segment are perpendicular to each other. So their slopes are negative or opposite reciprocals of each other. So if one of them had a slope of 2/7, the other would have a slope of -7/2. Opposite, negative reciprocal. If the negative was over on this side, then this one would be positive, just like that. Okay, so if we find the slope of the line segment, we can do the opposite reciprocal, and then we'll have the slope of our tangent line. Okay, how do we find the slope of this line segment? Slope of a line is change in y over change in x. So the change in y, I can start with either one as long as I start with the same on top and bottom. So if I start with this pair, this coordinate pair on top, I need to do the same on the bottom. So that's what I'm going to do. Start with 8 minus 0. Start over here with 6 minus 0. So 8 over 6, which simplifies to 4/3. So there is my slope of the green line segment. It's 4/3. So what is the slope of my reddish, pinkish, fuchsia-ish tangent line? It is the opposite reciprocal. It is -3/4. And now, boys and girls and cats of all ages, I can write the equation of this line. I have the slope, I have a point. Okay, so I'm going to start with my y equals mx plus b. I know my m, that's my slope, that's -3/4. I need to solve for b. I don't know it yet. I can get an approximate by looking at the graph, but this graph is not perfect, so I can't just look at that graph and say this is the y-intercept. I need to plug in an x and a y, and then I can solve for b. So that's what I'm going to do. I have that x and y. I'm going to plug in my 3 for x. Make that a little thicker. Come on. There we go. And then I'm going to plug in my 4 for y. And that gives me 4 is equal to -9/4 plus b. Now I'm going to add 9/4 to both sides to get rid of that and to solve for b. 4 plus 9/4. 9/4 is the same as 2 1/4. So 4 plus 2 1/4 is 6 1/4, or 6.25. And on the right, those cancel out, and I'm left with just b. So 6 1/4 is my b. I'm going to go back in here, change these back to x and y, and I'm going to replace my, there we go, 6 1/4. And there you have it. There is my equation of the line. Y is equal to -3/4 x plus 6 1/4. And I actually didn't do too bad of a job drawing that tangent line. It's not quite at 6 1/4, but I'm pleased with that. That's pretty close. Okay, so that is how you would solve that problem. That's my cat almost knocking over the microphone. And so that is how you would solve that problem using just algebra. If you have any problems that are giving you fits or you just think would be kind of fun to cover here, please post them in those comments below. And if this was enjoyable, if you liked it, if you learned something, if you just feel like being nice, please let YouTube know by liking, sharing, commenting, subscribing. You know the drill. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.